This is Arfan. Arfan is a boy who is full of curiosity. During school break, he was sent to his grandparents' house in rural area. One unique thing about Arfan's grandparents' house is that there are a giant satellite dish near the house. After hours of doing nothing, he suddenly felt the urge to play football outside the house by himself. However, he suddenly kicked too hard, causing the ball to flew and land on the satellite dish. Unfortunately, the satellite dish is too large. He accepted the fate that he will never get his ball back. But he suddenly thought about this one thing. How deep is the dish to the point where the ball can get stuck at the dish? So here's how Arfan solved his curiosity by applying the concept of parabola. The satellite dish has the diameter of 16 feet. The position of the receiver, which is the focus, is 6 feet from the base. So since the focus is above the vertex, so it means that the parabola opens upward. Therefore, we will use these equations. From the given focus is 6 feet from the base, so the value of P is equal to 6. Since it's already given the diameter of satellite is 16 feet, then the radius of the satellite is 8 feet, which is the value of x. So one of the endpoints of the diameter is 8y. Then the value of y is the height of the dish. So we will now substitute the values of x at P. Therefore, we will get the height or tip of the dish is 2.67 feet.
Situation 2. A group of engineers from the Fajar Builder Group company has been tasked to build a bridge to connect two rivers and has the following characteristics. First, the cable of the middle part of the suspension bridge is in the form of a parabola. Second, towers supporting the cable are 600 feet apart and 100 feet apart. 1 month later, during the presentation of the paper, Mr. Aiman, as CEO of Fajar Builder Group, asked what is the height of the cable at a point 150 feet from the center of the bridge. From the characteristic, we know that x is equals to 300 and y is equal to 100. By using the formula x squared equals to 4py, we substitute the value of x and y, and we get the value of p, which is 225 feet. Thus, x squared is equal to 900y. Since x is equal to 150 feet from the center of the bridge, we substitute it into x squared equals to 900y and get the value of height of the cable at the point 150 feet from the center of the bridge is 25 feet.
Situation 3. One day, while walking around a park, Aiman discovered that water fountains at parks that are used for drinking and decorations around the world have the same projectile motion of its water. This motion is called parabolic and its shape is parabola. Aiman is fascinated by how high and far water can be projected. He is thinking of making one himself, a water fountain inside a pond that he has in his backyard. Assuming that the water's velocity stays constant all the time and the origin is located at the water spout. Aiman wants to find out the water fountain's equation in standard form. The water is to be projected just 20 cm towards the inside of the pond and has a maximum height of 30 cm. The water also seems to be at 28 cm tall when the water is at 6 cm from the origin. This is the equation for standard form of parabola. Firstly, substitute h and k value into this equation. We are only missing p. To find p, substitute a point where water goes through. Value of p is determined. Thus, the equation of standard form for water fountain can be obtained.